Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 31 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 909, snakes and ladders. So we have solved something similar like this as part of our system design playlist. Okay, so in that we have solved one LLD problem, snake and ladder game. Okay, so this is very important. Okay, and many times this question is asked during the system design interviews, right? So if you are preparing for interview around so big companies, so definitely prepare for this topic as well, system design. So in this particular video, I have designed this snake and ladder game from scratch, in which there are two players, and both are playing. Like first player one is going to take his turn, then player second. So whoever reaches to the last cell first, he is going to win that game. Okay, so in this I have explained all the functional requirements and non-functional requirements, the design, okay, all the classes design, and I did coding as well. Okay, Java code is there for this particular problem, system design. So this is also very important, right? So now let's come back to our topic, this LeetCode problem. So in this problem you are given an n into n integer matrix board where the cells are labeled from 1 to n square in this style. Okay, which is starting from the bottom left of the board n minus 1 0 and alternating direction each row. All right, so here see, if you see this example number 1, so here the numbering is starting from this. Okay, so let's suppose your n value is 6, so we have cells labeled from 1 to n square. So n is 6, so that simply means 36. Okay, so 1 to 36 we have, right? And there is one pattern that we have to follow. Okay, and we are starting from this, right? So here if n is 6, so this is nothing but 6 minus 1 5 and 0. Okay, so from this we are starting, right? And alternating direction each row, right? So from here we are starting 1 2 3 4 5 6. Then here see, first we are moving from here to here, then we are moving from here to here. Okay, 7 8 9 10 11 12, then 13 14 15. Okay, until 36 it is there, right? Okay, so this is nothing but this style. You can say boost row feed on style, right? And then you start on the square one of the board, and in each move starting from square current, do the following. Okay, so we have to choose a destination square next with the label in the range curve plus 1, okay, or minimum of curve plus 6 to n square, right? So here if you are starting from this one, right? So next time you roll your dice, right? So you may get 1, okay, you may get 2, you may get 3, you may get 4, right? You may get 5, or you may get 6. Okay, so if you get 1, you are going to get 2 here, right? Same way here you are going to get 3, then here if you are going to get 4, then here you are going to get 5, then okay, and here you are going to get 6, then here you are going to get 7, then okay. Same way here also, after this 2, again you have choices now, 6 choices. Okay, if you get 1 2 3, okay, 4 5 6, right? Same way here also, everywhere, yeah, right? You have six choices again and again. Okay, same before this 3 also, 1 2 3 4 5 6. Okay, so you have six choices. Okay, so this is your first level, then this is your next level, then after that this there is also going to be one more level, right? So here okay, so here one thing, let's suppose here after this 2, if you get 1, what you are going to get? You are going to get 3. So tell me here, here in 2 moves I am moving to 3. Okay, first this move, okay, 1 to 2, then this. Okay, here I'm taking 2 moves, and here if after 1, if I directly get this 2, okay, in a dice, okay, I'm lucky, I'm getting 2 directly, right? So in just one move I'm moving to 3, right? So in the problem statement actually it is asking that we have to return the least number of dice rolls required to reach the square n square. Okay, least number of dice rolls. All right, so that simply means that this is a better way, right? This is a better way, right? So in my problem I will also keep track of whether I have already visited that particular cell in the past or not. Okay, so we will come to this later on. Let's read the problem statement after this. Okay, okay, so choose a destination square next with the label in the range curve plus 1 and mean curve plus 6 to n square, right? So definitely next one, and until 6 only we have choices, right? And here also we will check we are not going to move out of the board, right? We have to stop here, right? This choice simulates the result as a standard 6-sided die roll. There are always at most 6 destinations regardless of the size of the board. All right, okay, if next has a snake or a ladder, you must move to the destination of that snake or ladder. Okay, otherwise you move to the next. So here from 1, if I'm moving to 2, okay, and there let's suppose there is one ladder, okay, which is directly pointing to 15, then I will directly move to 15. Okay, I'm not going to use this 2. Okay, as soon as I come to this 2, I will directly jump to 15 because ladder is here. Okay, so this is the meaning of this line. So if next has a snake or ladder, you must move to the destination of that snake or ladder, otherwise you move to the next. Okay, the game ends when you reach the square n square, that final square. Okay, 36. Okay, so starting from 1, if we reach here 36, that's it. Okay, now a board square on row R and column C has a snake or a ladder if board of R of C value is not equal to -1. All right, so here we have given one board, right? So here if you see this input, we have given one board, right? So here these are the values in this board array, right? So this is nothing but a 6 into 6 size board. Okay, so board length is 6, so we have 6 into 6, 6 square. Okay, so here in the starting we have given -1, -1, -1. Okay, so here I'm writing -1, -1, -1, -1, -1, -1. Okay, then it is given -1. Okay, again -1. All here it is given all -1, so here I'm writing all -1. Okay, in brown color. Here see -1 and then minus here 35. Okay, then here -1, and here 13. So here I'm writing 13. Okay, so what does this 35 means? So current number is 14 at this particular position, so here 35, so 35 is greater than 14, so 14 to 35, that simply means there is one ladder. Okay, and here it at 17, here value is not -1 but it is 13, so 13 is less than 17, so definitely there is one snake, so it is ending at 13. Okay, so destination is given to us. Okay, at 17, 13 means 13 is the destination, and here it is a snake, right? Obviously that we are moving backward, right? And here at 14 the destination is 35, that simply means that there is going to be ladder. Okay, so this is board given to us. Okay, so at top from here only we are starting. Okay, and these are the rows 0 1 2 3 4 5, columns 0 1 2 3 4 5. All right, so this is how we have to fill all this. Okay, so here I'm writing -115. Okay, so here 15 means 2 to 15, right? All right, so this is given to us, right? So a board square on row R and column C has a snake and ladder if this value is not equal to -1. All right, the destination of that snake or ladder is board R and C. Square 1 and square are not the starting points of any snake or ladder. Okay, next, note that you only take a snake or ladder at most once per dice roll. Okay, if the destination to a snake or a ladder is the start of another snake or ladder, you do not follow the subsequent snake or ladder. All right, so here what is it saying? Okay, let's take the example. Suppose the board is -1 4 and 1 3. Okay, so 2 size is 2 now, so let's create 2 into 2 board. Okay, so let's say this is your 2 into 2 board. Okay, and let me draw here. Okay, 2 into 2 board. All right, so here we have -1, here we have 4, here we have -1, here we have 3. Okay, and if I just give the numbering here 1 2 3 and then 4. Okay, so here at -1, here 4, here -1, here 3. Okay, so here 3 means that from this 2 we are moving to 3, so that simply means there is one ladder. Okay, and here -1 comma 3 at this 3, if you see this is nothing but 3 now, right? So here at this 3, okay, so here -1 -4. Okay, so here it is nothing but showing 4. Okay, so that simply means that there is one more ladder here, right? There is one more ladder. -1 4 -1 3. Okay, 1 2 3 4, and here at 4, so that simply means -1 4 4. Okay, so there is one ladder. Okay, so -1 comma 4 now, so -1 4 here, so 3 to 4. Okay, and -1 comma 3, so here 3 is at 2, so 2 to 3 we are going jumping. Okay, so this is how. Okay, so this is 1, so this is one ladder. Okay, and this is 2 ladder. Okay, this is second ladder. Okay, and on the first move your destination is square 2. Okay, so yeah, so your destination square is 2, right? So here 1 2. Okay, right, your destination is square 2, you follow the ladder to square 3, but do not follow the subsequent ladder to 4. Okay, so in the first move if you are moving to this now, so here at 2 you reach, here it is saying 3, so you are jumping to 3. Okay, so this is your destination. Okay, you follow ladder to square 3, but then here also there is one more ladder now, so you are not going to follow this, but do not follow the subsequent ladder to 4. Okay, this is the meaning. Okay, so only one ladder we have to follow, right? Okay, we have to return the least number of dice rolls required to reach to the square and square, least number of rolls, and if it is not possible to reach the square, return -1. Okay, so here it is asking for least number of dice rolls. Okay, smallest path, minimum distance, right? And here we are traversing level wise. Okay, so let's think about BFS here. Okay, we are doing the traversal level wise, right? So at 1 we have these choices. Okay, then we have again these choices. Okay, so simply means we have to follow this BFS approach here. Okay, so now how we are going to do that? Okay, and since we are talking about the minimum distance, okay, minimum number of dice rolls, least number of dice rolls. Okay, so let's do that. All right, so now how we are going to do that? Okay, so how we do that? So we have to take one queue, right, in BFS. So in BFS you are starting from here only, right, in the starting, right? So you have to add this. Okay, so in the queue, let's suppose this is your queue. Okay, so in the queue you are going to add this 1 first. Okay, so now from this 1, right now your queue size is 1, right? And from this 1 we can move to this 2 3 4 5 6. Okay, we have many choices, right? So if I get a +1, but here at 2 you see there is one ladder also. Okay, to 15. So here if I just poll this, okay, right now queue size is just 1, so if I poll this, and now from here I can move to 15, right? Because if I jump to this 2 now, so 2 is taking me to 15. Okay, if I get 2 in the dice, I can move to this 3. If I get 3 in the dice, I get 4, reach to 4. If I get 5, okay, here, then I can also move to 6. Okay, if I get 5, 1 2 3 4, okay, 5, and if I get 6, I will move to the 7. All right, okay, and here just mark this as visited. Okay, we have already visited this. Okay, and we poll this, so we have visited this. Okay, I marked it green. So from 1, if you see, we are reaching to this 15, 3, 4, 5, 6 and 7. Okay, and we haven't visited these all this yet, right? So the in very our first move we are reaching to this. Okay, so mark them also visited. Okay, so mark this is also visited. Okay, 15, and this one also mark it as visited, this one mark it visited. Okay, we have already reached 9 in just one move. We have reached, right? This is unused. Okay, because whenever I'm going to reach to 2, I will definitely go to 14, 15. Okay, and we have reached to 6 in our very first move. Okay, we have moved to this 7 in very first move. Okay, so this is done. So now right now in the queue I have 15, 3, 4, 5, 6, 7. Okay, so here if you see in move 0, okay, current queue is equal to 1, so we are visiting square 1. Okay, so I'm marking 1 as visited, and then here dice 1. Okay, so we have ladder or snake found at 2 to 15. Okay, so definitely list ladder, right? So we move to 15, 3, 4, 5, 6 and 7. Okay, so in the current queue I've added 15, 3, 4, 5, 6, 7. Okay, so 15, 3, 4, 5, 6, 7. Okay, this is done, right? Okay, so this is done. Okay, this is step 1. This is step 1. Okay, because from here I'm starting, this is my step 1. All right, so here I'm counting the steps, so step 1 is done. Okay, so that simply means here I'm taking move 0, so you can say step 1. Okay, whatever you want, right? Now after that, simple BFS. Okay, now just take this out. Okay, from 15 we have to check. Okay, so if you take this out, so from 15 in just one move you can move to 16. Okay, in 1. Okay, if you in your dice you get 1, so you will get 16. Okay, so here I'm writing 16. Okay, and if you get 17, okay, if you get 2 in the dice, so you will reach to 13 directly. Okay, and we haven't visited 13 yet. Okay, so I'm going to add 13 here. Now same way here, if you get 3, okay, 1 2, if you get 3 you are going to visit this. Okay, here also mark this as visited. Okay, we also reached to this 13 also, right here. Okay, then here you get 18, same way 19, same way 20 and same way 21. Okay, 1 2 3 4 5 6, okay, until 21. Okay, 13 and then 18 and then 19, then 20 and then 21. Okay, right, this is done. Okay, so this is what you are going to get, 21. Okay, now here after this, okay, this is for 15. Okay, this is just for 15. Okay, now same way here after also you have to check for 3 also, right? So here for 15 until 21 you can move. Okay, now same way we have to check this also 3. Okay, 3 is there, right, in the current section. Okay, current section, so this is the current section of queue. Okay, until here we have to check. Okay, so step 2, right? So from step 1 we have choices. Okay, this is going to be our step 1 only. Okay, whenever we want. So from here if we're moving, so this is going to step 2. Okay, so we have to check the step 2 from all these choices, right? So from 3, if you get just 1, then you are going to get 4. Okay, but we have already visited 4 now, no need. 5 we have already visited, 6 we have already visited, 7 we have already visited, 8 and 9 we are going to visit this time. 8 and 9. Okay, 1 2 3 8 and 9. Okay, so just add 8 and 9 here. Okay, so let's say this is your queue. Okay, after this, so you are going to add 8 and you are going to add 9. Okay, so here see you have added 8 and 9. Same way for 4, 1 2 3 4 5, these are already visited. You can visit, you can also visit 10 now. Okay, so here you are going to add 10. Same way for 5, 1 2 3 4 5, you can visit 11 now. Okay, right, now same way for 6, you can visit 12. Okay, so I'm marking this 12 here. Okay, same way for 7, you can visit 1 2 3 4 5 6, you have already visited this 13 also. Okay, from 7, 1 2 3 4 5 6. Okay, 13 you have already visited now. That's it. Okay, so here see visiting square 7 and that's it. Okay, so 6 to 12. Okay, so in the queue you have now 16 13 18 19. We have already visited all this. Okay, 16 13 18 19 20 21 20 21 8 to 12. Okay, 8 to 12 9 10 11. That's it. Okay, so this second step is done, right? Now in the queue you have all these. Okay, all these items. Okay, in this green color. Okay, let me draw it like this until here. Okay, now again you have to do. Okay, so step 2 is done. Now you are moving to this. Okay, so now we still didn't reach this 36. Okay, as soon as I reach 36 for very first time, I have to stop. Okay, now from this 16, okay, you have this 16, right? So from this 16 you can move to 17, but 17 is directly moving to 13. Okay, so that's it. Okay, it's already there. Then you can move to 18. Okay, you can move to 19, you can move to 20, you can move to 21, and you can move to 22. Okay, 22 we haven't pasted yet, so here I'm adding 22. Okay, so 16 is done, right? So for 16 only 22. Okay, only this 22. Okay, now same way for 13. So for 13 you have already visited. Okay, you haven't visited 14 yet. Okay, now here see carefully. For 13, if you get one first time, 14, and 14 is directly leading to 35. Okay, so you are going to add 35 here. Okay, and now you have to mark this as visited. Okay, nice. So from 13, ladder snake found at 14 to 35. Okay, so you move to 35. Okay, then this is done, right? 13 is done. Okay, 13 also you can move to 15, 16, 17, all are visited only, right? So 18 and 19. Okay, all are visited, right? 14, all these 1 2 3 4 5 and 6 all are visited. Okay, 13. Now 18, check 18. 18 1 2 3 4. Add this 23 and 24. Okay, 23 and 24 for 18. Okay, and mark them as listed. Okay, so for 18, 23, 24. Okay, then next time 19. For 19 you have to add 1 2 3 4 5 25 you have to add. Okay, 6 we can move 1 2 3 4 5 6. Okay, 25 is not there, so add 25. Okay, so 25 is also done here. Now after that we have 19 is done, right? Now 20. For 20 1 2 3 4 5 6, add 26. Add 26. Okay, we still didn't reach to the final size. Okay, 26 we have added. Okay, then 21. So 21 you can add 1 2 3 4 5 and 6. Okay, for this 21. Okay, you can move to 27. Okay, so 27. So 26 already added, so now you have to add 27 only. Okay, so this is done. 21 is done, right? 21 is done. Now we have 8. Okay, so for 8 we have already visited everything. 9 10 11 12 13 14. Okay, we have already visited. 14 is related to 35 now. We have already visited. Same way 9, I think 9 is also already visited. 9 1 2 3 4 5 35 visited. 6. Okay, all are visited. 10 1 2 3 4 5 6. Okay, all are visited. 11 1 1 2 3 4 5 6 all are visited. 12 1 2 3 4 5 6 all are visited with 12. Okay, so now this step is done. Okay, 3 step is done. Okay, so here see now here where my move to ends. Move to ends here. Okay, move to ends here. So in the current queue we have what? 22 35 30 23, 22 35 23, 24 25 26, 24 25 26, and 27. That is right. Okay, so we have three steps done. Okay, now in the fourth step, okay, so you have 22. So from 22 you can move to 1 2 3 4 5 and 28. Okay, only 28 you can move. Okay, everything else is already done. Okay, so now this is the range, until here. Okay, so now 28 first I write it. Now this is done. 22 is done. Okay, 28 mark is visited. Then 35. Okay, now see 35 in just one move you can move to 36. Okay, you move to this 36. You are going to mark this. You are going to move to this 36 now, but 36 is what is required, right? Okay, so your current is nothing but n into n, this square. Okay, this 36. Okay, you move to this 36, right? So here you have moved to 36. Okay, same way you have to check for others also. So 29. Okay, same way you have to do. So in the queue, in the current queue, in the end you have to add, you have these information. Okay, 28 36. Okay, you can do this by your own. 29 30. Okay, 30 and 31. Okay, 32, right? And then 33. Okay, let's say you have this, right? So now you have visited all this. Let's say let all this stuff. Okay, now you are going to check 28. Okay, next time, but 28 you move to 20 34. Okay, you are going to mark the 34. You have added next time 34, let's say, right? And mark it. Now if you see in the current, okay, same way step 4 was already done, right? So now in this step, if you see the current is 36. Okay, so then you have to stop. Okay, so until then how many steps you have completed? 4. You have to just return this 4. Okay, moves. So this is a very simple code. Okay, nothing tough. Let's write the code. Okay, but this is a dry run. Okay, you can pause the video and you can try to fill this. Okay, queue. I don't think that anyone will show you this complete queue, right? How we are filling the values one by one, all this stuff. Okay, because this is very lengthy, but I have shown you, right? So this is dry run also. Okay, you can refer this one as so. Okay, so now let's write the code. Code is also going to be very simple for this. All right, so here what you need to do first, just check the board length. Okay, so int n is equal to board dot length, then create one boolean visited array. Okay, visited is equal to new boolean, and here you have to write what size is 36 now, so n into n plus 1. Okay, because starting from 1, right? It is starting from 1, right? So that's why this we have to write. Okay, and then take one q, and here integer, and here q is equal to new linked list. All right, and then in the queue you have to offer the starting point. Okay, q dot offer, the starting point is 1. Okay, then after this just mark this visited of 1 to true, visited of 1, just set it to true, and then moves. Okay, so we are going to start from 0 initially, and then simple BFS while our queue is not empty. Okay, and there is actually one more thing I want to show you, but let's write the code first. Okay, so while your queue is not empty, so first just calculate the size of queue, because we have to check all the elements. Okay, whatever there in our queue dot size, and then we have to run one loop, int I is equal to 0, I is less than size, and here I plus plus, and then inside this take the current element, int cur is equal to q dot poll. Okay, now here one base condition we will check if our cur value is equal to n into n. Okay, so in that case we have to just simply return the moves, right? So return moves. Okay, and now after this, inside this, in the dice we have total 6 choices, right? Int dice is equal to, starting from 1, dice is less than equal to 6, right? And here dice plus plus. All right, and now inside this you have to check the int next value. Okay, whatever the next value you're going to get, next is equal to the cur value. Okay, in this you have to add the dice value. Okay, if it is 1 first or 2. Okay, and here just make sure that your next value, it should not be greater than n into n. Okay, we only want to reach until n into n. Okay, after that we have to just don't want to move beyond that point. Okay, beyond n into n, right? So here we have to just continue. All right, so now here this is the thing that I want to tell you guys, how we are going to calculate the position. Okay, so at 2 we have one ladder. Okay, so in this it is saying that at 2, okay, at 2 you are reaching to 15. Okay, so now I want to calculate now this what is this row. Okay, row is this row is 3 and this column is 2. Okay, I want to calculate this position. Okay, right? So let's say okay, here I am writing one method. Okay, get coordinates, okay, coordinates, and here I'm just going to pass the next and n. Okay, so here let's say it is going to give I'm going to get the row as row at this pose of 0. Okay, and int column I'm getting int this pose of 1. Okay, so let's say this is giving get coordinates, this is giving me row and column. Okay, so I will explain this method a little bit later, but let's suppose that this get coordinates is going to give me the row and column. Okay, so now here uh, why I'm checking this. Okay, so here at this 2, if you see in our board -1 is not there. Okay, so if it is -1 then I'm fine. Okay, if it is -1, that simply means that there is no ladder or snake. But right now in our code, if you see, we have 15 here. Okay, we have 15 here. Now it is not -1, that simply means that there is something here, maybe a snake or maybe ladder. Okay, so now what we need to do. Okay, so since this is 15, okay, so using this 15 value I want to know that where I'm going to reach next level. Okay, so at this 2, I am right now at this 2. Okay, so at this 2 15 is there. Okay, at this 2 15 is there. Okay, so now how I'm going to do that, let's see. So here I'm writing if board row column, okay, row and column value, okay, if it is not equal to -1. Okay, so that simply means that instead of jumping from 1 to 2, okay, we are jumping somewhere else. Okay, so that simply means what I need to do here, we have to update our next to the value as board at row col. Okay, the value which is available here, board, row and col. Okay, so this value we have to update. Okay, row and col, this value. Okay, all right, so this is going to be my next. Okay, and now after that here one more check. If we haven't visited this next, okay, then in that case we have to first mark this as true. Okay, visited.next. okay, we don't want to visit it again for next time, right? Because we need minimum moves, right? So, and in the also here just include this in the queue. Okay, add this in queue. So queue dot offer, and here just add this next. Okay, this is done, and here your this for loop ends. Okay, and here just do one thing, increment the moves plus plus. Okay, moves plus plus, right? And then here after this just return a -1. Okay, if we are not reaching to this position. Okay, so just return -1. Okay, now here let me write the helper method, how we are going to convert the square number to a row and column. Okay, so here for this we have to write private int get coordinates, and here inside this you have to just pass int num int n. Okay, so now here, all right, so here you can see one thing. So let's suppose this is your matrix 1 2 3 4 5 6 7 8 9. Okay, this is a simple matrix. All right, okay, this is your matrix, and now let me just give the rows. So here this is 0 based indexing. Okay, 0 1 2, and here 0 1 2, right? Okay, now I ask you guys, tell me the position of this, tell me in which row 2 is there. Okay, so how you are going to do that? Okay, in which row 2 is there? So this is my question. So you are going to just do one thing here, the number is 2. Okay, just subtract 1 from it, right? And then just divide it with the n value. Okay, so n value here in this case it is nothing but your 3. Okay, so here what you are going to get, 2 minus 1, 1 divided by 3. Okay, so here this is nothing but 3 and 1. So here 3 0, so 0 only, here 1. So here this is the value that is coming out. Okay, 0. So that simply means that 0, right? Same way if I ask you as 3, so for 3 also you are going to get this 3 minus 1 divided by 3, that is nothing but 2 divided by 3, and you are going to get 0 only. Okay, but if I ask you for 4, so for 4 it is 4, I'm going to write 4 minus 1 divided by 3. So now this time what you are going to get, 4 minus 1 3 divided by 3, so you are going to get 1. Okay, so that is right. Okay, so that's why this is how we are calculating the rows. Okay, so this is numbering like this, 1 2 3 4 5 6 7 8 9. Okay, 4 row. But in our problem numbering is like this, opposite. Okay, starting from bottom, 1 2 3 4 5 6, then 7 8 9 10. Okay, then like this. Okay, it is starting from the bottom. Okay, so just do one thing now, just do one thing. Okay, so just update your row as okay, so this is this way. Okay, so I can say here let's say this is new row. Okay, new row, right? Row like this. Okay, like this. So in this, if I want to find out the value, okay, so how I'm going to do it? So what you need to do here, the total size. Okay, total size of this is 3. Okay, 3 minus 1 and minus 1, and just subtract the row value. So row value is 0 here. Okay, so that's it. Okay, so and 3 minus 1 minus 0, you are going to get 2. Okay, so that's it. Okay, 2, because I'm going to get something like this now. If I just oppose this order, 1 2 3 4 5 6 7 8 9. Okay, so now it is right now. So I just oppose to change it now. So if it I'm getting 0, okay, in this way if I'm getting 0, but in the end it will be there, right? Because we are starting from bottom. So I just subtract from n minus 1, n minus 1 by, because we are starting from 0 1 2, right? 0 1 2. Okay, we are starting from 0 1 2. All right, so that's the reason. Okay, all right, this is done. All right, okay, so now one more thing. Okay, so this is for row, right? Same with column also. If I ask you guys, tell me the column of this two, so you're going to say it is 1. So how we are going to calculate this? Okay, so simple now, simple. This value take 2 minus 1, and now instead of divide here use modulus with 3. Okay, and total n value is 3 now. Okay, total size, so 2 minus 1 modulus with 3, you are going to get here you did that now, remainder is 1. Okay, so that is nothing but your this value. Okay, 1. Okay, this is going to be correct for this 1 2 3 4 5 6, but here order is different again, right? This 7 is starting from here now, right? So this also we need to take care. Okay, it is not like this 1 2 3 4, then 5 6 7 8, then 9 10 11 12, but it is changing here. Okay, so at even indexes, if you see 0, this is 2 index, this is of 4. Okay, at even indexes, if you see, okay, if I just check this, okay, at even indexing, so if you see like this, so here you see this is a correct order, right? 1 2 3 4 5 6, then 13 14 15 16 17 18, then 25. Okay, but at odd indexes it is starting from this direction, 19 20 21, right? Okay, so here or in our case actually we are taking like this 0 1 2, so here you can say that in even indexes, okay, in even indexes we have to change the order. Okay, at odd indexes we are good, but at even indexes we have to change the order. Okay, because we are starting from 0 1 2 3 like this, not from bottom. So what you need to do now in that case, for even number of indexes, just change the order. Okay, just change the order, right? So now let's suppose if I ask you in this example, let's take this big example. Okay, so if I ask you find me the column of 32, find me the column of 32, so what you are going to get? So how you're going to get first? So here total is 36 6 na? Size of this board is 6. Okay, so column you are going to get like this, 32 minus 1, right, and divided with the n, which is nothing but 6. 31 divided by 6, you are going to get 1. Okay, 1. So 1 we are getting, but our 32 is at 4, not 1. Okay, so what you need to do, you need to change the order. Okay, so how you are going to change the order? Number of columns in total, since this is 0 based indexing, number of columns is 6 minus 1. Okay, 5. Okay, 0 to 5, right? So then you have to subtract this 1, okay, from it. So 6 minus 1, 5 minus 1, it is nothing but 4. So add 4, we have this. Okay, we just opposite the order, right? So this is what you need to do. Let's write the code, then you guys will get much better understanding here. Int, let me just maximize. Int row is equal to num minus 1, okay, and divided by n, okay, and then col is equal to num minus 1 for modulus with n you have to do. Okay, modulus with n, and then here you have to update the row because the rows are starting from bottom only every time, right? N minus 1 minus row. Okay, and columns, if the row is reversed, okay, so when the rows are reversing, when they are at even position. Okay, so here we are starting indexing from here na, 0 to 4. Okay, so even indexing. So here I can simply say now if n minus row, okay, modulus with 2, okay, if it is equal to 0, right? All right, so in that case just reverse the column. So here n minus 1 minus col. Okay, so actually this is the code for this, and from here I can simply return new int, okay, and here I can say row and column. That's it. Okay, so now let's run the code and see if the code issue. We'll try to fix that. So yes, there are some issues, so let's fix that. If board of row here is equal to, okay, if it is not equal to minus 1, right? Let's fix this and let's see. So here also line number 13, there's some issue. If current is equal to, okay, so here current is equal to, why I'm using m here, it should be n. Okay, if current is equal to n into n, okay, then in that case we have to return this. Let's run it again. All right, so now let's submit it. So see, our solution is accepted, right? And we have completed the May month challenge also. So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.